Now, what if you have a cubic polynomial that has a square like that? Okay. How would you draw this? Okay. So, again, this is x squared times x, so the leading term will be x cubed. So we know that the end behavior is like this. I also know that if you have x equal to 1 or 3, these are the x-intercepts, right? Because if you plug in 1 or 3, you get 0. Another thing that we know is that if you plug in 0, this is negative 1 squared times negative 3, so y-intercept is equal to negative 3. And if you try to draw the graph now, let's try to draw the graph. Here's 1, and here's 3. And here's negative 3. So you have these 3 points. And then the end behavior is like that. And if you just draw it naively, you might think like, maybe this? Yeah. And you would be wrong, okay?
Oh, no turn. Go down. Be none. Go down.
Okay, so over here it's right, and it should be increasing. The end behavior we know is correct. Now what I wanted to explain at this point is the effect of this squared. Okay. So let's try this. Pick something close to 1. Okay, so something like 0.9. Here's a question. If you plugged in 0.9 to this function, would you get a positive number or a negative number? Okay, if you plug in 0.9 and do squared, do you get a positive number or a negative number? It will be negative. No, it's positive. Why? Because if you square it, it's always positive, right? So if you plug in 0.9, it's always positive. How about this one? If you plug in 0.9 and you subtract, it will be negative. So positive times negative, it's negative, right? See, if I was asking you what's the value of y when you plug in 0.9, you would need to use a calculator to actually calculate. But if all I ask is it positive, is it negative, then you can actually answer that without needing a calculator. You just have to think, oh, square it will make always positive. So I just need to know what happens if you do 0.9 minus 3. That's negative, so negative times positive is negative. So I know that at 0.9, it's less than 0. It's negative. Good? Now, how about 1.1? What happens if you plug in 1.1? 1.1 minus 1? Well, I don't care. It's squared. It's always positive, right? Okay. 1.1 minus 3? Negative. Negative times positive is? Negative. So right after 1, it's negative. So what are we seeing? It's connecting, and then it's coming back. It's bouncing back. It's touching 0, but it's bouncing back. Why? Because there's a squared. Okay. Yeah. All right. And then it comes down, and then does it go through 3? Well, we know it should, because if it didn't and it went this, then it doesn't make sense, because then you would have 1, 2, 3, 4 turning points. You can't do that for a cubic. Cubic functions have at most 2 turning points, and already you turned once and you turned again, so you can't turn back. It has to go through. So that you know. But I still want to do the same kind of analysis at 3. If you had 2.9, what would happen here? Remember, this is always positive, so we only care about this. What's 2.9 minus 3? Positive or negative? Negative. Negative. So it's negative, right? What's 3.1? Positive. So it will be positive. So it's negative before and positive after. Okay? But here, it's negative before and negative after. Okay. So that's the graph. Let's do another one. Yeah, are you ready for super duper hard one? Okay, we're going to do something super duper hard. X minus 3 to the 4th, x minus 7 to the cubed. All right. X to the third times x to the fourth, what's that? X to what?
7.
7. With a minus, so what's the end behavior?
Negative.
What? So it's like negative 2x to the 7th. That's the highest order term. What's the end behavior?
That.
Is it this one or this one?
That one.
This one is the
Yeah.
negative one, right? Yeah, it's going down, right? Okay, so it's the one that's decreasing. So I know that the end behavior should be like this.
I have a question.
Yes.
How many points would you get if you just like put the arrows in like what way?
You know, I'm generous. I don't know.
3.
Maybe 2 points for having this.
Really? Okay.
Yeah, for a 6-point question or a 7-point question.
Okay.
All right. Okay, so let's see. Now you have 3 and then 7. Oh, that should be that. Okay. Now, before and after 3, when you plug in something slightly bigger than 3 and less than 3, let's see if there's a sign change. So 2.9. If you plug in 2.9, what is this? Is that positive or negative? How do you know? Because it's an even power. Any even power always gives you something positive, right? Okay, good. If you have 2.9 minus 7, negative, and odd power of a negative is still negative, times a negative, so it's positive. So right before 3, it's positive, someplace here. What about after 3? Right after 3.
Positive.
3.1, that's positive. 3.1 minus 7, negative. Negative cubed is negative. Again, times negative is positive. So what happened? Did it change the sign or did it bounce back? It bounced back. Okay, so what I'm trying to say is this. At even powers, graph bounces back. Very important, okay? Otherwise, it will pass through, right? So it's like this. It's going up this way, so it's like this, but it bounces back at 3. It touches it and it bounces back. Now it has to turn back because it has to go to 7. At 7, it's 0, so it has to cross that. Let's see. When you get to 7, will it cross over or will it bounce back? No, it will cross. Why?
Because you go
Negative.
Because 3
odd.
is an odd number, okay? If it's only when it's even, it bounces back. Otherwise, if it's odd, it will pass through. Okay. Now, to be slightly more realistic, because it's more than 1, it will kind of like touch and then go down like that. But you don't have to know. It just goes through. Okay. So that's the graph. Okay. So that's how you draw the graph of a polynomial when you have certain powers. If it's even, you make it bounce back. If it's odd, you make it go through. Yes?
Can you just explain that a little? Like, if it was 7, wouldn't that be 0?
Yeah, if you plug in 7, it will be 0, right?
But it's still even, I get it.
Yeah. So what I'm trying to say is, think about what happens when it's slightly before 7 and after 7. If it's like 6.9, then 6.9 minus 7 is negative. Negative cubed is negative. Negative times negative is positive. So it will be positive right before 7. But if you plug in 7.1, 7.1 minus 7 is positive. Positive cubed is positive. Times negative, it will be negative. So right after 7, it will be negative. So the graph actually crosses over to the other side because there's an odd power. If this was like 6 or 8 or some odd even number, then the graph will turn back. Okay, that's what I'm treating.